Hello, and welcome to my Graphing Rationals Functions video. This will be my third attempt on this video to get this going. I'm just having technical difficulties, so bear with me. Alright, we're going to begin to look at one particular example. This will be part 1, and the other video, it'll be a different graph, and that'll be part 2. So, let's go ahead and get started with this first example so we can get this going. The first example, we have 2x squared plus 5x minus 3 all over x squared plus 2x minus 3. The first thing we need to do is take this function and simplify it. And that's how we're going to do this, okay? If you're in my class, this is nothing new. If you're in someone else's class, this is how we do it. We go ahead and simplify our function. So, we have the function 2x squared plus 5x minus 3 all over x squared plus 2x minus 3. Okay, we need to go ahead and simplify that. The first thing we need to do is factor the top. The top can be factored by multiplying a times c, which becomes a negative 6, and then what two factors of negative 6 when combined together will give you a 5. Hopefully you said 6 and a negative 1. We're not finished. Please do not put x minus 1, x plus 6. It'll be wrong. You need to go in reverse because we have a leading coefficient of 2. So we need to figure out where that leading coefficient comes into play. 2x squared. This will be a negative 3. 6x right here, and a negative 1x right here. Alright, what does this row share? This row right there shares a 2 and an x. What does this other top row share? That just shares an x. So now we have our two leading numbers. So we will continue. X times what number will give you a negative 1x? Well, if you said negative 1, then you're in good standing. The last one, 2x times what will give you 6x, and that will be a 3. Does that give you negative 3? Yep, we're all good to go. So our numerator is 2x minus 1 times x plus 3. Now, our denominator is a little bit more simple. There's a leading coefficient of 1, so we don't need to do all that. We can simply say x plus 3 times x minus 1. Now, at this point, we're going to factor out anything that's the same in the numerator and the denominator. If you said that, you're good. Our solution becomes 2x minus 1 times x minus 1. We need to list our domain restrictions. X cannot equal negative 3 and positive 1. How did I get that? My domain restrictions come from my unfactored form. Okay? We need to make sure we include the domain restriction of x plus 3, and that's where we got the negative 3 from. Okay, I'm going to go back to my other slide. Alright, so from here we can begin to write our domain. Our domain uses our domain restrictions. Obviously, that makes sense, right, you guys? Our domain uses our domain restrictions. Imagine that. So we're going to take our domain restrictions that we found, and we're going to put it in there. I'm going to zoom in a little bit so I can write them. How many union symbols are we going to have? Well, we're going to have 2 because we had 2 domain restrictions. So we start with negative infinity because we read from left to right of the graph when we're finding the domain. Negative infinity to negative 3. Union. Negative 3 to 1. And then union 1 to positive infinity. And that will be my domain. Okay? Now, as we continue down, holes. Were there any holes in this graph? You might ask yourself, well, what is a hole? A hole is removable discontinuity. Okay? Removable discontinuity means what factors were simplified out. We removed something from our rational equation. Rational function, excuse me. What did we remove? We removed an x plus 3. So we would take that x plus 3, okay? We would take that x plus 3 that we removed, and we'd set it to equal to 0, and we'd find our x coordinate of our whole, and that will be at -3, okay? Now, to find my y coordinate of my whole, to find the y coordinate again of your whole, you're going to take that -3 that we found, okay, that x coordinate, and we're going to plug it into the reduced fraction, okay, the reduced rational function. The reduced rational function, if you remember, I'm going to erase this and I'll put it up top, is 2x minus 1 all over x minus 1, okay? So we'll take that -3 and we'll plug it in. 2 times a -3 minus 1 all over -3 minus 1. What will that equal? Well, if you said 1.75, then you are correct. How did I get that? 2 times -3 minus 1 is a -7, and then -3 minus 1 is a -4. 7 divided by 4 is 1.75. So my y coordinate will be 1.75. Now, you can do two things. You can go ahead and plot that whole, or you can wait till the very end and check off things as it goes. I'm going to go ahead and plot that whole. So I'm going to zoom in at -3 and 1.75. I'm going to put a open circle at that location. Now, that might be hard for you guys to see, so let me see if I can do a better job at getting that. That's still terrible. That's okay. See, that's not going to work either. There we go. All right, that's about as good as Miss Smith's going to get it. Okay, so -3.175. We've graphed it. We're good. Now, vertical asymptote. You're going to take this bottom right here, and your vertical asymptote is the domain restriction of your reduced function. Your domain restriction of your reduced function will be x is equal to a positive 1. So we will have a vertical asymptote at 1. And I'm going to draw a little dashed line there. Okay, horizontal asymptote. Horizontal asymptotes are found by looking at your highest degree of both the numerator, highest degree there, and your denominator. Well, what do we see? The highest degree in both the numerator and the denominator match. So when they match, that should tell you, let's look at our leading coefficients. We have 2, and in the denominator we have 1. So our horizontal asymptote is going to be y equals 2. So I'm going to do another dashed line. Horizontal asymptote is a horizontal line through positive 2. Now, if we have a horizontal asymptote, we will have no slant asymptotes. So you need to write none. Do not put 0. Do not put some random number. Don't leave it blank. You need to tell me it is none. Okay? Now, after we find all of our asymptotes, we go into x and y intercepts. The first thing that we're going to look at is our x-intercepts. And if we're doing this, our x-intercept, we're going to go back to our reduced fraction. Excuse me. We're going to go back to our reduced fraction. Okay? We're going to go back, if I can get this erased without pressing a bunch of random buttons. We're going to go back to our reduced fraction, and we're going to set our numerator equal to 0. Remember, our numerator is this sucker right here. Okay? So we're going to set that equal to 0, and we're going to solve. So 2x minus 1 equals to 0. Add 1 to both sides. 2x is equal to 1. Divide by 2. X is equal to 1/2. So our x-intercept is going to be at 1/2, 0. On the graph, we're going to put a dot right there at 1/2, 0. Okay? Now, my y-intercept are my constants, okay? And we can look at them in two places. Now, if you're in my class, I had you look at them from the original function, right here. -3 over -3. What does that equal? That equals a +1. Now, would it matter if I looked over here and I said, well, of the reduced fraction, will I still get the same? Yes, you will still get the same. It'll still be 1/1, which is a 1. So, my y-intercept is equal to 0, 1. So I'll go over to 0, 1 and put you guessed it, another dot. Okay? Now, last but not least, our end behavior. When we talk about end behavior, we're talking about as x goes to -infinity, what does y go to? Y will go to, if you said our horizontal asymptote, then you're good. Y will go to 2. Okay? And the same thing, as x goes to +infinity, y will go to, you guessed it, 2. So everything is approaching our horizontal asymptote 2. Now, if we've been following along, graphing as we go, we should start to see in this right here, in this box right here, this right there, that we have several pieces of information to get that curve. What will that curve look like? Remember that an asymptote will hug your graph will hug your asymptote. Excuse me, I'm tired, you guys. Alright? It will be that dog running that fence line that we talked about in class. So you need to make sure you draw that line. Now, from there, once we have those points, we will look at where do I graph the other piece, because there is another piece. Now, I told you in class you can do some test points. Well, Miss Smith, what should I test? We know we have the curve here. We need to figure out where the curve is on the other side of the vertical asymptote. So I'm going to take 2 and 3, and I'm going to create a table and see what I get. Okay? If I use the order pair 2, okay, I need to find what my y is. So I'm going to take that 2, I'm going to plug it into my original equation. So, if we do the math, that should give us a y value of 3. So, at 2, 3, I will have a curve, or I'll have a point on that curve. Now, at 3, we're going to have a y value of 2.5. Okay, so I'm going to go in there and plot that point. So now you should be able to see where that curve is, how it's going, hug that asymptote, and draw your arrows. It's going on and on forever. Okay, so now we have graphed this function. It's a lot of information, it's a lot of things to do, but if you go step by step, you will be successful. Good job, you guys.